Hello friends, in this final session on SAS, I'll be talking about few statistical techniques, namely regression analysis, ANOVA test, simple linear regression and multiple linear regression. Linear regression is the starting point of econometric analysis. The linear regression model has a dependent variable, that is a continuous variable, while the independent variables can take any form, that is continuous, discrete or indicator variables. A simple linear regression model has only one independent variable, while a multiple linear regression model has two or more independent variables. The linear regression is typically estimated using OLS, that is ordinary least squares. Now, talking about regression analysis, we can also perform regression analysis between dependent variable and independent variable. The dependent variable here is mass per gallon, which is dependent upon the independent variables weight, length and foreign. So, the command used to perform this regression analysis is regression model MPG is dependent variable and weight, length and foreign are independent variables. Proc reg data is equal to auto, model MPG is equal to weight, length, foreign, run. Looking at the p-values of the output, statistical significance could be gauged. The screen shows the output of regression command executed. The reg procedure model 1 dependent variable MPG, number of observations read 26, number of observation used 26. Here, by looking on the output generated, we can see that price and weight have negative relation, whereas the next two variables, those are length and foreign, are statistically insignificant. This can be inferred by looking at their p-values, which are above 0.5. Now, talking about ANOVA test. Lastly, we will perform ANOVA test where we will check the mean of mass per gallon for the category of data, that is domestic and foreign is same or not. We can perform this test using proc GLM and the command for the same would be ANOVA test if the mean MPG is the same for foreign and domestic cars. Proc GLM data is equal to auto, class foreign, model MPG is equal to foreign, run. Here, we can see that the p-value is less than 0.5, hence it is statistically significant. Now, let me start with importing the CSV file. Now, let us start our session by importing the CSV file needed. For that, the command needed to be given is proc import out is equal to work.data. Data file is equal to C /econometrics /data /regression _ auto.csv. dbms is equal to csv, replace, get names is equal to yes, data row is equal to 2, run. Now, the data that we are using for this example contains the information shown on the screen. we can see that we have 26 observations of the cars. Then mass per gallon mpg, which will be a dependent variable, we want to explain. Weight of the car is shown in the next column, besides which I have generated weight 1 variable by dividing the weight by 1000. Hence, the weight now derived is in 1000 pounds. Next is the price of car in a particular year in hundreds. Next column shows whether it is foreign or not, and these are the variables that we will use as independent analysis. Now, starting with descriptive statistics. The first thing we will do is to look at the descriptive statistics using proc means with mpg as dependent variable and weight 1, price and foreign as independent ones. Descriptive statistics, proc means data is equal to data, where mpg, weight 1, price, foreign, run. The output would be as shown on the screen. Here, as we can see, there 26 observation with mpg as 20.923 mean, weight is about 3000 pounds, 6651 for price and 0.29% car are foreign. Detailed descriptive statistics. We can also look into more detailed descriptive statistics by using proc univariate and variable mpg. Detailed descriptive statistics. Proc univariate data is equal to data, where mpg run. The output is shown on the screen. Here we can see so many statistical details like mean, median and mode, the percentages, highest and lowest observations to outliers, and can thus be determined. Talking about correlations. Next thing we can do is to find out correlation using proc cor, putting in equation of all the variables we have by executing the command correlations. Proc cor data is equal to data, where mpg weight 1, price, foreign, run. The output of executed command would look like here we can see that the highest correlation is between weight and mass per gallon, that is mpg, which is independent and dependent variable, is minus 0.8. Now, talking about plotting the data. Now we can also plot the data using proc g plot, and we are plotting mpg multiplied by weight 1. Plotting the data, proc g plot data is equal to data, plot mpg into weight 1, run. So this is how it looks like when the data plotting command is executed as shown on the screen. On the x-axis, we have independent variable weight 1 and on y-axis we have dependent variable mass per gallon, and the observations are scattered in the xy plane. When we observe the data, we can make out that it has a negative relation. So when we are trying to fit a regression line, we will generate a line as close as possible to all the points. Now let me talk about simple linear regression. Here we will take one dependent variable and one independent variable as the definition of simple linear regression states. The command for the same would be simple linear regression proc reg data is equal to data, model MPG is equal to weight 1, run. The results are as shown on the screen. The reg procedure model 1 dependent variable MPG. The third table shows parameter estimates on which we are going to concentrate. Notice that we have an intercept and next we have an independent variable weight 1. The third column under the heading of parameter estimates are the coefficient of the variables. The interpretation of these figures say that if weight increases by 1 unit, which in our case is 1000 pound, then we will have a reduction of 5.53 mass per gallon, which is our dependent variable. Here I use the word reduction because the parameter estimate shows a negative sign. Now we want to know whether this coefficient is significantly different from 0, and to do that we look at the standard error, also the t-value, which is nothing but parameter divided by standard error, and lastly the p-value, which should be less than 0.05. As we can see that p-value is less than 0.05, we can say that it is significantly negative relationship. We can also look into the ANOVA table for model, error and total variation. Note that we have one independent variable, so the degree of freedom df is 1. Also, the total variation comes by total observation minus 1, which gives us 26 minus 1, that is 25. In this table also the p-value is less than 0.05, which means it is significant in nature and hence also called significantly different than 0. Now, as we can see on the screen, we have some interesting graphs. These graphs is somewhat similar to scattered plot diagram that we saw earlier. On the x-axis, we have independent variable weight 1 and on y-axis, we have dependent variable mass per gallon, that is MPG, and the observations are scattered in the xy plane. The circles are the actual observation and the line is the regression line. The circles are the actual value for dependent value y and the regression line would contain the predicted values. Now, the next graph of residual is nothing but flattening of this regression line as a straight horizontal line, and we can see that the difference between actual observation and predicted value is the error. This is the best thing about simple linear regression, that is, has only one dependent and one independent variable, and hence it can be easily plotted. So now let us talk about multiple linear regression on this example. Here we will take one dependent variable and more than one independent variable as the definition of multiple linear regression states. Here we will take MPG, that is mass per gallon, as dependent variable and weight 1, price, and foreign as independent variables. The command for the same would be multiple linear regression proc reg data is equal to data, model MPG is equal to weight 1, price, foreign, run. The results are as shown on the screen. The third table shows parameter estimates on which we are going to concentrate. Notice that we have an intercept and next we have now more independent variables, that is weight 1, price and foreign. The third column under the heading of parameter estimates are the coefficients of the variables. The interpretation of these figures will again be same as mentioned earlier, with only slightest difference in the value of weight 1 as minus 7.12, which says that if weight increases by 1 unit, which in our case is 1000 pound, then we will have a reduction of 7.12 mass per gallon, which is our dependent variable. Now we want to know whether this coefficient is significantly different from 0, and to do that we will look at the standard error, also the t value, which is nothing but parameter divided by standard error, and lastly the p value, which should be less than 0.05. As we can see that p value is less than 0.05, we can say that it is significantly negative relationship. We can also look into the ANOVA table for model, error and total variation. Note that we have 3 independent variables, so the degree of freedom df is 3. Also, the total variation comes by total observation minus 1, that is 26 minus 1 gives 25. In this table also the p value is less than 0.05, which means it is significant in nature and hence also called significantly different than 0. Now, as we can see on the screen, we have some more interesting graphs. But as there are many more variables added now, it becomes really difficult to understand from graphs. Hence, tables are better option. So friends, let us summarize today's session. Today, we discussed the analysis part of SAS, in which we looked upon how to perform regression analysis on dependency of dependent variable over independent variables and ANOVA tests. Also, we learnt 2 important statistical techniques in SAS, namely simple linear regression and multiple linear regression. We also saw the interpretation of different variables and values shown in the output table as well as the graph plotted for the same. I hope the session would have given you brief insights on the analysis part of SAS program. Thank you for joining us.